Good afternoon or good day, wherever you're watching from. Welcome to my YouTube channel again, where we solve electrical problems, physics, and mathematics. But for this series, we are just based on electrical for now. When we are much satisfied with the videos we put out there for the electrical series, we will dive into physics and mathematics as well. But if you do have something in mathematics or physics you would want me to solve, you can forward it on my mail or my WhatsApp handle in the bio description above on the channel. So what are we looking at today? We are looking at series parallel combination of resistors. This is just a continuation of the second class we had. So I just want to solve this one more problem in it, and then we look at power, because we much more get encounter with power as we do calculate some things. So I would want to touch power before I get into the main deal of the day, which is Kirchhoff's law, both KCL and KVL, Kirchhoff's current law and Kirchhoff's voltage law. We'll treat that today as well. So the question we have before us today is this, which says find the value of R on the total current when the total power dissipated in the network is 16 watts. So let's say solution for a start. Please, if you haven't subscribed to this YouTube channel, please subscribe. Click on the like button as well as the notification button, so that whenever we drop a video you will get notified. Thank you for doing that. Solution. So total power, we have it as what? 16 watts, right? Total power, we have it as 16 watts. Total current, we are now asked to calculate the total current, where we remember, if you remember in our first class, we talked about the triangle rule, where we said V is equals to IR and I is equals to V over R, I think so. So here we're dealing with power, so and we're asked to calculate the current. So total current, let's say T current, will be equal to what? Will be equal to T current, let's say T current, which is I, is equal to I as current, equals to P over V, where you know power is I square R, and power similarly can be IV, and from power equals to IV we can say I is equals to P over V. This is where we got this. So we can now say total current I is equal to P over V, which is equals to 16. What is our voltage given? 8 volts, which is equal to 2 amperes. That's our total current in the circuit, and we were asked to calculate what? The value of R. So to calculate the value of R, we can say total resistance from A to B point, RAB, is equal to what? It can still be as P over I square. Do you believe that? I believe it. If you remember, we say P is equals to I square R from here. So this is just a change of subject. So P was given as 16, and our I square now is what? 2 squared. We have gotten the current, which is equals to 16 over 4, which is equals to 4 ohms. That's our RB. So to find the total resistance between AB, similarly, it's given us what? Let's say similarly RAB is equal to, if you look at from this point, node A or terminal A to B, we have two four resistors in which two are connected in parallel to each other respectively. So now what we will do is treat them respectively. 2 times 8, we said, over 2 plus 8, right? Plus 4 times R, the second side, over 4 plus R. I hope you know what I'm doing and you're understanding what I'm doing. So if you remember from, let's say this is 1 and this is 2. So from equation 2 above, you know that R is equal to 4 ohms. Therefore 4 is equal to, this times this is 16/10 plus 4 plus times R over 4 plus R, right? Alright, let's go this side, which we have 4 is equals to 1.6 if you divide 16 by 10 plus 4 times R over 4 plus R. I hope we're progressing. So what do we do? We have this equation now. Let me give us some space so that we would solve. So what was our equation? Our equation was 4 is equal to 1.6 plus 4R when we multiply over 4 plus R. So what do? Multiply both sides by 4 plus R, right? When we do that, what do we have? We would have 4 plus R here is equals to 1.6 times 4 plus R, right, plus 4 R over 4 plus R times 4 plus R, where this goes with this, and this would be 4 plus R is equals to 1.6 4 plus R plus 4R. Am I correct? This would be 16 plus 4R is equals to 0.4 plus 1.6 R plus 4R. So what do we do now? We collect the like times. Here we would have 16 minus 6.4. 6.4 is equal to minus 4R, and it crosses to the other side, excuse me, plus 1.6 R plus 4R. The same as saying this and this would go. So 16 minus 6.4 would have 9.6 is equal to 1.6 R. Divide both sides by 1.6, we would have R is equals to 9.6 over 1.6, which our final answer will now be equal to 6 ohms. So that will be the final answer for our resistor value. I hope you are following diligently. So as I said earlier, I would only be solving one question on the series parallel combination of resistors, and we would go straight into power. So I want us to deal with that. Electric power. So in electrical circuits, voltage applied to a conductor will cause electron to flow. Voltage is the force. Voltage is the force, and electron flow is the motion. Let me repeat myself. In an electric circuit, voltage applied to a conductor will cause electron to flow. Voltage now is the force, and electron flow is the motion. The rate at which work is done is called power. So power is the rate at which work is done. Power is equals to work done. Rate at which work is done. Because the rate at which work is done. So, and is represented by a single P. If you remember in our previous examples, P. Power is measured also in units. The units is in watts. Which is capital W. The unit is in watts. You understand, and it can be represented as well by the symbol W. Watt is defined as the rate at which work is done in a circuit when 1 amps flow with 1 volt applied. So power is measured in watts and is represented with the symbol W. The watt is defined as the rate at which work is done in a circuit when 1 amp flows with 1 voltage applied. So let's dive deeper. Power consumed in a resistor depends on the amount of current that passes through it, the resistor, for some given voltage. You understand what I'm saying? What I mean there is that the power consumed by a resistor will be dependent on the current passing through that resistor at a given amount of voltage. So power can be expressed P equals to A times I. This E is what we call as voltage, V. You understand? Or you can say P is equals to VI. You understand what I'm saying? So power can also be calculated by substituting other components of Ohm's law. What are the other components of Ohm's law? Current. So in the same way, power can be P equals to I square R, and power similarly can be equals to E square of V over R. I hope you're understanding. So having done this, this is the resistance value, or the resistor, or resistance value. This is the voltage, and I is always the current. I is always the current. I hope you understood. So let's now dive into an example. Let's say calculate the power in the given circuit. So you can now say P is equals to IV, which is equal to 12, which is equals to 2 amperes times 12, which is equals to 24 watts. So similarly, you can say P is equal to, since you're given your resistance value, you can now say P is equals to I square R, which is equals to I square is 2 square, 2 amperes square times 6, which is equals to 24 watts. So similarly, the answers are giving us the same thing. In the same manner, you can say P is equal to E square over V, or E square over R, or V square over V square over R, where this is something as this is equal to, what's the voltage, 12 squared all over what, 6, which is equals to 144 over 6, which is equals to 24 volt. So you see, either way we go, our answer is now giving us the same thing. So let's look at another simple example so that you would understand more. An electrical equipment let's put in bracket 120, no, not in bracket 120, sorry, in bracket lamp, electrical equipment. Let's assume it's a lamp. Let's say it's a lamp rated 120 volts and 100 watts. Using Ohm's law, calculate the rated value of resistance of the lamp. You see, so you can now see from power, our previous formula, P is equals to V squared over R. We can transform in this equation to something like, say, R is equals to V squared over P. You see, just a change of subject. So now we can use this to calculate R is equals to 120. Our rated voltage was 120 squared all over what's our rated power. Power was 100. So R now will be equal to let's say 14400 all over 100, where this and this will go, and R is now equal to 144 ohms. So this will be the rated resistance value of this particular lamp. So I hope you understand what I did there. So having done that, let's look at another simple example. So using Ohm's law, you can say V is equals to IR, remember, and I is equals to V over R. So we have voltage as 120, we have our resistance value as calculated before as 144, which is equals to 0.833 amps for the current.